I first want to start off by saying that this is it's a very young framework here for the top 10 for LLM apps. It's evolving. There were a lot of contributors to this, and the reason why that I chose to use the OWASP LLM to be the underlying foundation for this presentation is so that it's backed by a framework, and so that there's something to go back and reference. Now, this framework, the OWASP top 10 for LLM apps, is going to evolve over time as these techniques become more researched and more known, because one of the things, like I just said, this is a very young framework, and some of the techniques that are in this haven't been really well developed yet. Some of them are still being researched, and some of them are still theoretically. So let's start with the first one. And again, this is going to be high level in introducing you to the topic. We'll go more in depth into these tomorrow in the workshop. So LLM 01, so prompt injection. This is essentially what we just did. The prompt injection is a technique that is predicated by prompt engineering. And it is the use of creative techniques, and by the way, again, we're not using a lot of detailed slides or anything like this because it's a power talk. So I'm just going to talk here. Hopefully you don't mind that. So the prompt injection technique is where you're using special techniques. You can use direct injection. And it's really, in many cases, it's just synonymous with creative prompt engineering. And the direct prompt injection is when I'm using a creative prompt specifically in an LLM-enabled application. And then indirect prompt injection is where I'm using a third-party source or something to insert. So, for example, some techniques are hidden links, hidden prompts within a website that you go to. And so if you're, for example, if you're scraping the web content and you gather all that content and it grabs a link with a prompt, it can trigger certain things. You can embed prompts in applications, in documents. So those are some of the different examples of indirect prompt injection. And then again, direct prompt injection is when I'm actually inserting a prompt into a user input field, like a chatbot, okay? And so this is going to be the most used attack vector. This is one of those things to where almost all other attack vectors are initiated by some form of prompt engineering or prompt injection when it comes to large language models, because the main way that we're interfacing with large language models are through prompts, okay? So second to prompt injection is insecure output handling. So if the prompt is where we're inserting our instructions to the language model, then the output is what happens after that. And so, and I'm sorry, let me go back real quick. Preventing prompt injection. So in order to prevent prompt injection, you're going to deploy, number one, and this is for both of these. So you're going to deploy two main different types of techniques. So the first one would be your standard input validation, input filtering, just like in regular software development or web application development and those sorts of things. Also, the other way to do this, and so for the insecure output handling, it would be validating and verifying the output. And I'll talk about that specific aspect here in a minute. The prompt, the other technique to mitigate these would be putting in, and we'll again, this is something we're going to work on a lot tomorrow, is actually putting in preprocessors and other types of proxies and guardrails to prevent certain input from actually even getting to the model. Okay, so it's one technique, and then the same thing on the output. So insecure output handling, that's essentially certain attack vectors. There are creative prompting and creative input to where we're actually using the injection, we're using the model to provide access, in a lot of cases, provide access to something on the user's machine or the server, whether it's an attack on the model itself or whether we're using, say, a plugin. So there's malicious plugins. There are several different areas to where either someone who developed a malicious program, or just where I'm actually attacking a server where I'm getting my prompt injection to produce some sort of output that gives me access to sensitive information or even the operating system. Training data poisoning. So, and I would say for the most part, so far, these are really in order of kind of importance, severity, and use case proliferation. And so training data poisoning is, and if you caught the panel earlier, we talked a little bit about training data security or kind of the privacy of data and things like that. So training data poisoning is where you're putting in malicious data, fictitious data, misinformation directly into the model. And so this happens whether there's several different ways and attack vectors this could happen, but this can happen where if I know that my data is being used for training data, I can put in false misinformation or malicious data into that, okay? You can also, another version of training data poisoning is if I'm creating a model or training or fine-tuning a model that I'm going to provide to the public, like on sites like Hugging Face, then I can create malicious models that have misinformation, that have malicious intent and code and things like that. So it's basically intentionally poisoning or providing misinformation or malicious information into a training model. And so protections against that are, and there's not a lot there, which is simply making sure that you're getting your models from valid sources, making sure that you're getting your training data from valid and verified sources. And so this is a battle that we're currently fighting. And if you remember in kind of the early days of natural language processing and creating chatbots, there were people that were able to whether red team or do this maliciously, providing this sorts of, I mean, they were providing horrible things to the model, right? I mean, they were making it extremely biased and racist and doing some really bad things, making the output from the chatbots really horrible. So that's kind of an early version of training data poisoning. And we're going to be fighting this particular battle for quite some time as we learn how to provide quality training data and how to even clean up models, if that's even, possible through fine-tuning and training. Model denial of service. So denial of service is a common vulnerability in terms of cybersecurity. It means you have rendered something out of service or you're unable to get to a particular service, like a website is out and things like that. If you've ever used ChatGPT, then you've probably experienced model denial of service. The most common form of this isn't even meant to be malicious. It's just simply, there's so many people using the model, using ChatGPT, exhausting the resources to where you can't use it anymore. I mean, I just can't get to it. And a malicious intent of model denial of service would simply be, I'm purposefully exhausting the resources. And so the ways that you protect against that are rate limits. That's why you see it in ChatGPT, why they have rate limits, because they're preventing resource exhaustion so that everybody can use the service. Supply chain vulnerabilities, to me, this goes hand in hand with training data poisoning. It's essentially making sure that the LLMs that you're getting, the plugins that you're getting, anything that you're actually getting in terms of the models themselves, the applications themselves, are validated and verified and not malicious. But there's also other things where, if, for example, earlier I talked about the websites where you can provide malicious links and malicious prompts inside of those things. So this is all part of supply chain vulnerabilities, where you're getting your applications, where you're getting your data. It contributes to supply chain vulnerabilities. It's a very vague term. It's a very broad term. That's why I feel like that this one kind of goes along with other particular attack vectors that we'll talk about. Sensitive information disclosure. I think this one should be a little higher up on the list if we're talking about them in order of priority. But sensitive information disclosure, I think, is self-explanatory. And a lot of people are concerned about this, using sensitive information, having my sensitive information being used as training data, and then that getting exposed. And so this is whether I'm using Copilot in GitHub, or whether I'm trying to find out answers on my own, say cybersecurity policies or anything that's internal and sensitive, if you're using an open API, like an OpenAI API or the Claude 2 API, all that data is going out to the web, out to their API, and it's getting stored. And in many cases, they'll use that to retrain models. So you definitely don't want to use any type of sensitive information when you're talking to APIs, when the data is going out. One way to prevent against that, aside from just making sure you're not exposing your sensitive information or your source code, is to use closed models or your own local or open source models that you use locally, and you're not relying on a public API. Insecure plugin design. I think that, again, this should be above the supply chain vulnerabilities. I think this is a subset of supply chain vulnerabilities. But if you have a ChatGPT Plus account, you've already seen where you can use plugins. And the problem with a lot of these plugins is that there's not a lot of information given. There's not a lot of exposure to the permissions. And so there's a whole subsection of vulnerabilities that can happen here. But you can have someone who intentionally develops a malicious plugin that can access your sensitive data, that can access your computer, take advantage of things. We'll actually take a look at some of this tomorrow. Or you can just simply have a plugin that requires or requests a lot of permissions that it doesn't even need. Kind of like when you download an app on your phone, and it's something like a calculator app, and it wants access to your microphone and your camera and all of this stuff, right? So these are examples of insecure plugins, and whether it's malicious or accidental, or, well, in the way that you can't talk today. The way that you prevent these are simply verify and validate where you're getting your plugins from, or if you're developing plugins, use proper security or secure software development methods and techniques. To me, excessive agency is an extension of insecure plugin design and permissions issues. So this is a perfect example, is where the plugin requires or requests much more permissions than it actually needs. And so it just kind of goes along with those. So again, preventing that is, if you're developing it, you want to make sure that you are being reasonable with the permissions, only asking for what you truly need. Or if you're receiving plugins, you're getting a plugin, you want to validate and verify that. And again, this is something we'll talk about in more depth tomorrow about how to protect yourself, what to look for. Over-reliance. This is kind of more of an ethics concern, in that as a society, in this explosion of interest in generative AI and large language models, if we use this as a core method of information and content creation, as opposed to just in an augmentation manner, then we run the risk of falling victim to misinformation, deep fakes, and things like that. And that's really kind of where a lot of these conversations are going with the ethics and LLMs, and our over-reliance or potential over-reliance on this. And so we want to make sure that we are a good comment for a lot of these, okay? Human in the middle, human in the loop. We want to make sure that we're validating and verifying a lot of this, whether it's something we're receiving, something that we're creating, because I'm sure you'll see throughout a lot of these talks and presentations and workshops throughout this conference, you'll see that there's going to be a lot of talk about how we augment and how we use the data, and a lot of ethics talks. And so we want to make sure that we have a human in the loop. We want to make sure that we're not falling victim to LLM hallucinations and that sort of thing. So, and model theft. Again, this one, model theft, I think kind of goes along with the sensitive data thing. So if you're creating your own you're creating your own models with your own data, you're training them and fine tuning them because you want that data. You want that ability to be able to discuss sensitive things and to model sensitive information. than in not go out to an API. Well, when you do that, you run the risk of exposing sensitive information if someone takes that model and steals your model. And really the only way to protect against this are going to be standard cybersecurity principles, right? So you want to make sure that you're securing your servers and your hosts or the databases where this information is kept. If you absolutely must be creating models with sensitive information or proprietary information, you want to make sure that you're following standard cybersecurity practices to protect what that information is.